Hello, and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. My name is Wenxi Chen. I am an AI software engineer on the founding team of Juji Inc. I specialize in developing practical AI technologies and solutions with neural-symbolic machine learning approaches. At Juji, I have been focusing on building and improving cognitive AI assistants, integrations of AI assistants to solve real-world problems, as well as democratizing their adoption and making them accessible for everyone. For more on my background, see the bio widget on your screen. Okay, for those of you who may be unfamiliar with ACM or what it has to offer, here's more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing and learning center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides access to the ACM Digital Library, the world's most comprehensive database of computing literature, leading publications and global conferences that draw top experts on a broad spectrum of support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize in Computing Awards, and the ACM Code of Ethics, a collection of principles and guidelines designed to help those make ethically responsible decisions in professional practice. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Okay, before we get started, I would like to quickly mention a few housekeeping items shown on the slide in front of you. If you are experiencing problems with the slides or audio, refresh your browser, relaunch the presentation. If you have questions during this talk, please type them into the Q&A box at any time and click the submit button. I will organize the question as Michelle speaks, and we will try to get to this as many as possible. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available, and check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you will see a survey open on your screen. Please take a minute to fill it out to help us improve our tech talks. You may also open the link to the survey at any time from the resources window. You can use the widgets on the bottom to share the presentation link with your friends, as well as tweet comments and questions using hashtag ACM Learning. We will be watching for your tweets. We also have a community discourse page to continue the discussion after this webcast, including questions we won't be able to get through during the Q&A session. So today's presentation is Democratizing AI, Creating Cognitive AI Assistants with No Coding by Michelle Zhou. Michelle Zhou is a co-founder and the CEO of Juji Inc., a California-based company that develops cognitive AI assistants in the form of chatbots. Michelle is an expert in the field of human-centered AI an interdisciplinary area that intersects AI and the human-computer interaction. Michelle has authored more than 100 scientific publications on subjects including conversational AI, personality analytics, and the interactive visual analytics of big data. Prior to founding Juji, she spent 15 years at IBM Research and the Watson Group, where she managed the research and development of human-centered AI technologies and solutions, including IBM Watson Personality Insights. Michelle serves as Editor-in-Chief of ACM Transactions on Interactive Intelligent Systems and an Associate Editor of ACM Transactions on Intelligent Systems and Technology, and was formerly the Steering Committee Chair of the ACM International Conference Series on Intelligent User Interfaces. She is also an ACM Distinguished Member. Michelle, without further ado, take it away.
Thank you, Wenxi. Let me actually Hello, everyone, and it's really a great pleasure to be here and share our work toward the effort of democratizing AI, and especially in the context of creating cognitive AI assistants. To start, I want to actually, for the sake of this talk, to give a very quick definition of AI. I'm pretty sure in the audience, you probably have learned and knew many different definitions of AI. So in our term, the definition of AI is quite straightforward and quite simple. We're talking about the machines, and especially a piece of hardware and software, or maybe the combination of both, that have human skills and can perform human-like tasks. So here, I gave two examples of human skills. So on your left, this is about the language skills. This type of skills really actually distinguish us humans from other animals. And after reading this particular paragraph, and you can actually sense the emotion, the sentiment, the type of content the authors tries to convey. And also another type of skills is visual perception skills. For example, humans would be able to recognize there is some kind of artificial flowers on this robot's neck, and there is a computer display in front of its chest. So this is called the visual perception skills. So the next question comes very naturally. So why is AI very hard to acquire, very hard to build? This is because of several reasons. So one reason is that human skills are very diverse and complex. So I mentioned about the language skills. So here is actually the chatbot I chatted on the website. And I obscured the brand name just to not embarrass this particular brand. So as you can see, this chatbot was asking about my name. And then my answer is, my name is chatbot. But then you see the response is kind of off, right? Say, great to meet you. My name is chatbot. So they thought my name is the whole input is my name is chatbot. But humans would not make such mistakes because humans' language skills can easily detect the semantic concept, semantic meaning, and extract the entity. And the second, in the human-to-human conversation or interactions, humans also exercise what we call soft skills. You can also know as social emotional skills. So for example, when you talk to certain people, you feel like it's very easy to talk to. It's very easy to have the conversation. The conversation is very pleasant. It's because they have that kind of a social emotional skills to make you feel that way. So soft skills are even harder to learn, harder to acquire. And given the state of art of AI, and also given the existing tools and systems, it's very costly to acquire AI skills for basically the human skills for computers, to teaching basically AI. So one it is normally it requires a group of AI experts, AI expertise, and as well as programming engineers. So not only it requires expertise and programming skills, even with such skills and expertise, it still takes a long time to create a powerful or capable AI. So normally you will say it will take us maybe months or sometimes years to create something that can be used in a practical field. So when we started the Juji, what we really want to do here is to address those challenges, and in particularly make the acquisition or make the building of the AI simpler, easier, to reduce those kind of costs and make it more accessible to everyone. So this is our definition of democratizing AI. It really touches upon two aspects of it. The first aspect is to the AI creators, to the AI, what we call the owners or the managers. So we want to help them to teach machines human skills, even though without AI expertise or engineering expertise. So for anybody who can make a PowerPoint, can use a spreadsheet, they should be able to use the tools, the very intuitive graphical user interfaces to create a capable and useful AI. And the second part of it is because of democratizing the creation of the AI, then we can democratizing the adoption of the AI, which means that we're not making the AI assistants a premier or a privilege to certain people. Instead, make them accessible to everyone. And so that's our two goals of democratizing the making as well as democratizing the adoption of AI. So in the rest of the talk, I'm going to actually use an example how we are democratizing the creation of a cognitive AI assistants, and also through a set of demos which Wenxi will help me to show. So in this particular rest of the conversation, presentation, I wanted to actually touch upon two topics. The first one is how we acquire cognitive intelligence for machines, which is mostly like a piece of software. Also, how we make it accessible to people who don't have actually AI skills, who don't have programming skills. But as a start, I wanted to give you a sense of what do we mean by cognitive AI assistant. So I'm going to actually transition to a live demo, and then from there, I will discuss what kind of cognitive skills this AI requires in order to perform in this way. So right now I'm coming here, it's our actually website, but don't try this right now. You can try it afterwards. So then I will start, this is basically a welcome chatbot on our website, right? So this is basically tells me what it can do, right? Because during the COVID-19, there is so much misinformation. So a group of folks have used our platform, creating the Jennifer, which is a chatbot that offers trustworthy and reliable COVID-19 information, and from reliable sources like CDC, like the World Health Organization. So now you can see this is about one. So the question is one. I do have a question. I said, tell me about Juji. And then this chatbot actually understands that and say that, oh, this is an ambiguous question because the chatbot's name is also Juji. So it said if you meant Juji me, and it would be me, right? And then if you meant to Juji the company, and then it's the company, right? Then I said what's cognitive AI assistant? Because I mentioned the cognitive AI assistant himself. So in a human world, cognitive intelligence means the human's abilities to understand, remember. In a machine world, it means very similar things, capacity to understand, remember, right? And I said how does cognitive intelligence make you special? And it tells you what the cognitive intelligence will do, right? Better understand users and then personalize the help and also greatly improve user experience and so far, and so right. So in this case, I would say is demonstrate your special power. Let's see. Interest and one ask me your shopper DNA, right? Say, so remember, I just come here, right? So I say this, what's my shopper DNA? So this is the one type of intelligence that shows the cognitive intelligence, which I will talk about. It is through the conversation, it analyzes the user's text and trying to infer the user's unique characteristics so they can personalize that decision making. So just say this one, although it may not be stabilized at this point, but it's based on 29 words. It's talking about what potentially my shopper DNA will be look like. Then I said, so what else can you do? Okay, so then I don't want to ask this one. I say, can we play the game? Can you guess the number I'm thinking between 0 and 9? I don't know what the number is thinking. I said it's 5. So as you can see here, it is. This is also another feature of a cognitive AI. I can start with the user to take initiative, but then the system actually took initiative in this case of asking me a number, right? In this case, sorry, incorrect, right? Now it's my turn. So this actually now the system takes control again. Please think of a number between 0 and 9. Let me know when you're ready. And I said, so I'm telling you, and then I'm thinking number is 8. So let's say if we can be right, right? So I said, ready? You say 7. No, you're wrong. That's how it makes sense because I don't have a human brain to. So cannot really guess. So it's kind of like a have fun. You can afterwards you can go. So this one takes down if you're done asking questions, right? It said it's I want to say what else, right? Again, as you can see at the beginning, the system takes initiative, will ask me if there's anything it can help with. So I ask the question. The system actually takes control depending on what questions I ask, depending on what situation we're in. But now, and they say. Now it takes to say this, I say I'm done, and then takes one say, I'm curious, what type of work do you do, right? I said it's, I'm a computer scientist, and I create AI just like you. So I'm going to stop here. So this gives you a little bit flavor as how the cognitive AI assistant will actually engage you in a mixed initiative conversation, which I will explain in a minute, and how it handles the context. And you will see more actually in Wenxi's demo as well, right? So I'm going to stop it here and going back to my slide. Let's actually go behind the scene, see what's behind the scene to make this particular conversational AI agent behave in this particular way. So then the first thing first it is because the current conversational agent, this cognitive AI system we call it performs different tasks for users through the conversation. So the first thing first is we have to model the human-computer conversation. So according to the psychology of a human-computer interaction, this is from Stu Card and his colleagues' work back in 1983. Basically, the human-computer interactions consists a set of what we call the exchanges between them over time. And each of these exchanges you can actually consider defined as the goal to achieve a particular task, and also includes the method one or more methods to achieve that goal. So for example, most of the people are familiar with the GUI, right? So thinking about you go to the GUI interface, graphical user interfaces, you see a set of page. That's to achieve the goal. For example, making a reservation. That's one goal. You have to enter your information, click the submit button, right? So that's kind of a set of interaction there. Because human-computer conversation is just a special form of a human-computer interaction, so you can also think about the very similar way. But instead of just the goal, if we're talking about it's a conversation topic, it still serves a particular goal. And then the methods will become a conversation logic to drive the conversation forward. But unlike the regular, where the familiar, where the human-computer interaction, most people familiar with the GUI-based, and this one has the one of the very interesting attributes for human-computer conversations that machine can initiate, which you saw, right? When the machine starts to say, how may I help you? But then the users took over, ask the questions, and then the machine can take over to say, hey, if you want to play a game, fine, but give me a number to guess, right? So that's why I take initiative. So user can take initiative. But in a normal GUI basis, the user hardly can take initiative in terms of start completely a new GUI because it cannot automatically do that, right? But in a natural language conversation, it's much easier for user to take initiative and start a completely new thread. And you will see more in our actually follow-on demo. So let's go even deeper. So from the work by Gross and Steitner in 1986, it's a similar paper about anatomy of human-computer interaction. We're talking about the core structures of the conversation is attention, which means what objects, what things the conversation is centered around. Then intention, what is the intent, right? So for example, if you make a reservation, it's the intent, but the attention would be the number of people, size of your party, the time, and the date, right? So then it's a discourse structure. How those different conversation topics or goals, if you will, threaded together, and either they thread together to accomplish a bigger goal or accomplish each of the sub-goals. And moreover, in this discourse structure, there's two sets of flows, the main flow and the side flow. Let me give you an example, concrete example on this one. So as you can see, this is a real conversation, and you will see actually later on in the live demo as well. So this is C represents computer, H represents human. This is a very kind of a simple conversation about making a restaurant chatbot reservation, right? So the computer starts with, how may I help you today? I can help you to make an order, or I can help you to make a reservation, right? So the human say, I can make a reservation, and then the chatbot continue asking about the reservation details. But however, at this point, the human deviates. Instead of answering the question of giving the reservation details, the human was asking, if I spend more, could I get a discount? And in order to deal with this one, the computer followed the human by actually describe what kind of a discount this person might get. It depends on how much do you spend. If you spend $100, that will be 10% discount. But as you can see, interestingly enough, it is the computer will actually remember the context that it's making a reservation and come back to remind the user to continue the reservation making process. So you can say the main flow is a system initiated, and the side flow is a user initiated. So that's why traditionally we call it a mixed teachable conversation, which is essential to create a very useful and effective conversational AI agents. That's why we also call that in order to have the effective conversations, they must have those kind of skills of supporting mixed initiative conversations. Then you might asking, so what else? What other skills in order to help the cognitive AI assistant to actually better help the users, better accomplish the tasks? This one we're talking about it is two sets of skills. One, definitely communication skills in order to carry on the conversation effectively and efficiently. And then there's the soft skills, like I mentioned earlier, the social, emotional skills, which I also describe more. So let's start by looking at the language skills. The language skills, as I mentioned earlier, it is really abilities for humans, but here we wanted for the machines to understand and respond with natural language. So I give an example here, but then let's go deeper to take a look at it is by dissect what specific language skills AI assistant really needs in order to be successful in a conversation. So one is called the semantic interpretation, which is understanding the gist, the semantic meaning, you can also say intent of the conversation. Second one is information extraction. This case, according to the anatomy of the conversation, which means talking about extract attention, because you wanted to use this information to complete the task. It's extract attention of the from user expressions. Another one, of course, is synthesize response. So the next of the few slides and demos, I will focus on first two because we have done most of the work in this particular two areas. So let's start with the semantic interpretation by looking at the challenges. So challenges it is, let's say, for example, in application process, like many of you probably have applied for jobs, maybe applied for graduate schools, like online MBA programs or maybe PhD program, you are asked about normally to write an essay, write small essay, 250 words or maybe even 100 words to answer some of the open-ended questions. So let's say the chatbot is used, our assistant AI is used in this kind of a situation of collecting applications from applicants. One of the questions is what's best of you? So as you can imagine, the type of responses could potentially come in, right? It's highly diverse. Some are with very complex meanings like this, right? And also sometimes could be even ambiguous, irrelevant, like the last one is relevant. So then next one, we want to show you from a live demo how the chatbot, how the AI assistant could potentially recognize this kind of diverse expressions and respond to them appropriately. So Wenxi, are you ready to show a quick demo on this one?
Yeah. So I just pulled the demo.
Actually, I have to stop sharing. 1 second. Oh, you can go ahead. Yeah, I stopped sharing, I think.
Yeah. So I already sharing my screen.
Mm-hmm.
So for example, here is the question. And then let's say we put the.
So as you can see, what Wenxi is typing here it is, it's a very, it's a one particular type of expression, right? User input, and then a system is able to recognize such an expression and respond properly. Wenxi, can you show maybe alternative expression? Let's assume that it's another user, and how would it respond?
Okay.
As you can see here, it's like one of my examples. So this is a real user expressions we have collected from our actually system. As you can see, it's very different user response. And of course, it also triggers very different AI response. So Wenxi, can you try an irrelevant response and see how the system recognizes and then handles it?
Mm-hmm.
Say, as you can see, the user in this case they didn't really answer the questions, but answer the question, but instead actually giving an irrelevant one. And but the AI is able to recognize and give appropriate and encourage the user to give a more relevant response, right? So let's go back for a minute. So I wanted to kind of to share with you what's behind the scene here, right? So what's behind the scene? I'm going back to my slides here right now. What's behind the scene? What do you show here? It is that in our particular case, we use divide and conquer methodology. because the training the end-to-end conversation requires a large amounts of data. So keep in mind, we really want to democratize the AI, which is make it accessible, but smaller organizations, even some medium organizations, do not have sufficient conversational data to train. So that's why we adopted the topic-based divide and conquer approach, which you can train by each conversational topic. In this case, you don't need a large amount of data. And the second part, we combined unsupervised and supervised learning. For example, unsupervised learning would be helping the machine to identify the major semantic themes and then use that to train different types of responses, right? So kind of retrieval-based responses. And then I also have to do fine-tuning because the normally off-the-shelf models are not sufficient, not good enough, right? So for example, I give example here. It is if you have those training sets, I like fish, I love seafood, I hate fish, right? So by default, they may think I like fish and I hate fish are more close to each other than I like fish and love seafood. But semantically, from a human point of view, the first two obviously are more semantically relevant rather than, and they're semantically actually opposite. I like fish and hate fish, right? But if you don't give those specific examples, specific training samples, then the off-the-shelf model does not work. So I'll do fine-tuning. So I'm not going to go into the very low-level detail to tell you exactly how it is done, because our 2020 paper has actually detailed some of the approaches and the hybrid approaches of unsupervised and supervised learning to support this type of semantic interpretation. So then, as I said, semantic interpretation is to help the computer to detect the intent of the users. But that's not sufficient, because we also have to identify the attention within the particular intention. So for instance, in this particular example, it is if you want to make a reservation, they need to identify the certain concepts, which is reservation details, right? The size of a party and the date the person is planned to come. And also, if you are asking about the hobby, you need to extract actually what is the hobby. And similarly, like the example I showed you earlier, which failed to do so, it is if you ask the user's name, it better actually extract the right name versus just assume the whole sentence, the whole thing would be a person's name, right? So basically, the challenge here is many domain concepts, and it's very complex and vague data relationships sometimes. Like an example is here, Mary and Michelle, they are the same person, but with different names. Of course, they have another busy, noisy information like this one. So then I want to ask Wenxi to show you another demo before I actually describe our approach. So Wenxi, I'm going to go ahead. Yeah.
Okay.
So this is a demo to show you how the system actually extracts very different, what do you call it, concepts, intention, attention, right? Understands the intention, but actually extracts the attention from different sentences. Like you can see here, it is, I'm usually busy working, but when I have time, I like to play piano, right? So it understands the intentions about the playing music, but then actually extracted the play piano, the concept, right, the entity. So can you show another, if it's possible, to show another alternative to show which is very different expressions. They can still extract the relevant attention from the particular user expression. So I love playing basketball. That's another one, right? So physical activity, so understand the overall semantic meaning, but in the meantime, and extract the concept, in this particular case, a basketball, right? So that's a kind of, you can see this one. So let's go back right now to go with screen sharing. So I'm coming back to my screen sharing. So as you can see, in order to extract the information, or in other people's terms called entity from one, it's two tasks actually in one. One task requires it understands the intention still, the semantic one. And then you have to interpret the semantics first. Then you have to extract the concept, which was called attention, right? So currently we have used the neuro-symbolic approaches, which means it is the data-driven approach. We use the like deep learning approaches to actually train our models to recognize the different types of intention, which is semantic concepts, very similar to what I just talked about in the previous one. But in the meantime, in order to extract those things, we have actually combined with the symbolic approach. In particular, we use the optimized finite state machines, which is to actually extract the patterns from the semantically relevant expressions. So as you can see, there is, in this case, the patterns about the playing basketball, playing piano, and of course, later on you will see they also can extract different types of concepts like the number, date, and time, and so on and so forth. So it's really combine both approaches and to make this work, especially make it work is to actually cut the work for the other people, which you will see later, basically pre-trained models and also the pre-trained even the information extraction models. So I'm going to move on. Talking about the second set of skills, it's still called the communication skills, but unlike the language skills, it's called attention and memory. So you can think about in your human-to-human conversation, right? You probably would hate to talk to a person who doesn't actually follow the context or who doesn't remember anything you just talked about. That would be crazy, right? So in this case, in a human-computer conversation, you don't want your AI to do that either. So you want the AI to actually understand the focus of attention as well as to memorize what's going on. So in this case, actually, I want Wenxi to show you particularly how to handle two particular type of things. Because of a context, users gave incomplete expressions. How do you handle that? Second part of it is users can interrupt the computer anytime. How does the computer should handle the arbitrary interruptions but still maintain the context? So Wenxi, could you go about yours again?
Okay. Yeah.
Mm-hmm. So in this case, it is you will see Wenxi will show you two conversational topics, but the user expressions are exactly the same, but the responses are very different because of the context. So this case, what do you enjoy doing outside of work? What about you? So this is interpretation, even though it's incomplete expression, which means about ask the chatbot, what do you enjoy doing outside of work, maybe in your spare time, right? It's time to continue. So what do you say? Yeah. So in this case, Wenxi, you can also interpreting this expression in context, right? So they say, what's your favorite movie? And then he said, what about you? Again, it's a switch of the context already. Before we're talking about what your hobbies, what do you do, what do you enjoy doing during spare time? And now we're showing that what's your favorite movie? And now if the same expression, what about you? Of course, it's interpreting in this context would be what's your favorite movie for the AI? It would be say whose favorite movie? Oh, Harry Potter, right? This is what's favorite movie. Maybe you can say same as yours, right? So you can see that. So this is one. Yeah, so it's good. So then I want to show you Wenxi. Now let's go to show another demo, which this is one, it's a restaurant chatbot. We've switched context right now. This demo is intended to show you how the computer should understand context, not just understands, but memorize what's going on and maintain that context, push conversation forward. This is what I mentioned a little bit earlier, right? So let's say this is asking for a reservation. This is the kind of example I gave earlier. and then we have 5 people. But remember, the computer was asking about the details of the 5 people and the time and date, right? But they didn't give them a date. So in this case, instead of asking, so Wenxi, can you just disrupt? In this case, maybe just say this one. If I spend a lot, can I get a discount or something like that, right?
Okay, so here I'm asking a coupon.
That's okay. That's good. Yeah. Could you check if it's still valid? And now it's about the coupon right now, right? So, but before I answer this one, because users sometimes their brain is really actually what do you call it? It could be jumping from one topic to another topic, right? This is like our conversation as well. Can give a discount. Again, this is a second level of interruption. Again, so what do you spend in, say, you spend $100 or something like that. Yeah. So this case, you can get 20% discount, right? And also the calculating get 20% discount. And then they said it is, now it still remembers before they started one was on a coupon one, right? So if you answer this coupon one, then you will see they still remembers the whole overall goal is about making a reservation. This should go back automatically to actually to do the resuming a reservation task, right? So as you can see, this is supposed to be how the conversation goes, which the computer really remembers the focus of the attention and understands the current focus of attention, but also remembers the overall conversational context and maintains it properly to ensure task completion. Okay, so I think we're done with this demo, right? So then we're going back to my yeah. I'm going back to the my slide. So as you can see from Wenxi's demo, the challenge here is a user virtually can make a transition to any topic. You can say any state, right? But within that topic, you also have different types of substates. So for example, clarifying the topic or refine that topic, asking a follow-up question. So this means that this could be potentially unlimited depth of a unlimited depth of a conversation, right? So it creates a combinatory actually explosion problem, which means that the computer needs to continuously remember, tracking, and not just that, and figure out where this transition particularly can be head to, right? So this one. So this case it is currently we have been developing what we call the optimization-based approach, because in this kind of a transition, even to estimate how the user's input may lead to a next transition, it requires what we call the prediction, right? By maximizing the satisfaction of a set of constraints. So I use this here as a maximization set of constraints. So what are constraints? So one constraint is the context. So you saw earlier before, what about you? Even it's the same thing, they may match with many, many topics, but the most likelihood match with the current context, which is either talking about what's your favorite movie or what do you like, what do you enjoy doing during the spare time, depending on context. Also depending on task. Task, which means that is if the conversation is about the AI to elicit information versus customer service, so you can prioritize the task. Like what we're doing right now, I'm making a presentation right now. I may not take your question until I'm done with my presentation. So you see, task differences can also reflect upon how the conversation will be handled. Another one is time. So for example, if we already talked about for 20 minutes, our allotted time to 25 minutes, then the AI needs to make a decision as how deep the conversation should go, right? And another one, what I call it is the conversational etiquette. So for example, how much do you want to please the user? Just to follow the user's flow anytime, anywhere, or you want to curb the enthusiasm of the user, right? So depending on the policy it is, of course, there are other also constraints, like, for example, the user's personality and also the brand's image, right? So that you can also thinking about all these constraints together. So we have been developing optimization-based, which is going to be data-driven optimization-based approach to figure out the probabilities of each of the importance of each of the constraints. So that's what we're basically been working on. So now I'm going to transition to our next topic, because given my time, I can only touch the surface of what we have been working on. It's about learning and decision making. This is all about soft skills. So as I mentioned earlier, and when you are talking to a certain people, you feel like it's very pleasant, right? It's because this person understands you and can empathize with you or your situation, and make you feel that you are being heard, and they really genuinely want to help you. So we wanted to make an AI assistant to behave in this way, to have that kind of a social emotional skills, intelligence, if you will. So currently we have been working on it is once we're chatting and once the conversation is going on and the system is dynamically analyzing the text, and actually we could read between the lines to infer the individual differences, also their unique characteristics. So then, based on these insights, the computer can personalize the decision-making to guide user behavior. So then, our current approach, which, by the way, this is also published article from our published article here, it is, so in our current approach, it is, we want to infer the hidden, what you can call the latent human characteristics from the text. So the theoretical basis of this one is called the psycholinguistics, and with also modern psychometrics testing. So our approach is a hybrid approach of IRT, which is stands for item response theory with big data analytics. So all these different types of evidence could be a word use, the frequency of word use, syntactical patterns, emoticons, or maybe punctuation marks, actually signal these latent traits, latent characteristics. So basically the whole idea is here to use those evidence, infer this latent trait. Again, I don't have time to go through the detail of this one, but if you're interested in this area, you're most welcome to look up the paper or contact us for more details. So what's this for? The best use for this one is to really personalize decision-making, what we call the personalized AI help. So as you can see here, it is, we have two examples. So one, it is customer, when the user who is action-oriented and impatient, another user who is very thoughtful, cautious, but indecisive. So they both are the prospective students' request for more information on the available financial aid programs. And giving this same request, and the AI can really give very different answers, right? For this, Emma and the chatbot can say this, I wish maybe she wants, because she is patient, action-oriented, want a quick summary. So actually it presents the information in a quick summary. But for Lucas, the AI can actually present even a program comparison table to help Lucas actually make a decision and to help his actually analytic aspect, analytic actually habit, analytic thoughtfulness type of it. As you can see, it's really personalized decision-making, personalized kind of help to each user. And then the next one I want to quickly to go talk about it is, now I talked about how we wanted to acquire different type of skills to make a cognitive AI. But now, as you can see, it takes a lot of effort, right? But we don't want other people to replicate our effort or have to collect amounts of data to go through the painful process we have to go through. We have to go through. So in this case, it is we package them, so then we can enable people to do so and without coding. So then I want to go back to recall that the anatomy of the conversation. So if you can think about the conversational design, which is don't think about the programming aspect, really from a high-level aspect. So the conversation is really around the two elements, key elements, roles of the conversation, which means you, a user, and the computer, two roles, right? Computer and the humans, and the content of the conversation. And around the two roles, around the two elements, then we have a key structure, attention, intention, and the discourse structure. So we don't care about attention, intention right now. It's because if we have a pre-built AI to detect an intention, attention, then the other creators of AI do not need to worry about it. So the creator only need to worry about the main flow and the side flow, which means it is what do you want the machine to do, right? It's from a role point of view. What is the content? And then a side flow, you can then think about it is what do you want to support the users to do, which means the user's role, and what's the content you want to touch upon. So once you think about this way, it becomes very simple. So it's really three-step process. Define the main flow, which means it is what the agent, what the AI needs to do. Then decide the side flow, which is the content for the users to touch upon, the users to actually inquire about. Then we can automatically generate an AI with out-of-the-box intelligence. So I'm going to stop here. Wenxi, maybe you can go to your quick demo, to last demo, and then.
Okay.
Go ahead. Yeah. So here, let's show that you're going to create a chatbot from scratch. As you can see here, it is a template, right? So he uses a blank template, which means you can customize in many different ways, right? So in this case, we want to create a very simple restaurant recommendation chatbot to recommend, suppose that it's a seafood restaurant, recommend dishes of seafood dishes, right? So in order to make a recommendation, you want to ask them, what's your favorite dish, right? So then ask them what's your favorite dish. Then we can ask a user whether they are allergic to anything, because the reason this one it is seafood, there may some of people may allergic to certain parts of the seafood, or maybe some of the ingredients, maybe the condiments. So this one. So then you can see when she now actually needs to customize a little bit for seafood restaurant. So you might say, I like fish or something, right? I like, right? You will see, even though it's not the precise match, but it's still, you can understand because by semantic one, I like crab, I like, salmon, yeah. You can lower down and create a little bit, seafood lover, right? So because in this case it's just, remember it's a seafood restaurant. You want to cater to the people who love seafood, as you can see here. So he customize. Then you want to say allergic, right? Allergic to it. So as you can see, if you knew how to do PowerPoints, you can do this very easily just by adding those kind of questions you might want to ask. And yeah, you can customize the one to ask, maybe use some keywords just for simplicity, right? And then maybe say garlic, or should I allergic to garlic? Okay, I think it's sufficient, maybe. Just yeah. So I want you to allergy. Yeah. Okay, good. Okay, so Wenxi, can you scroll down to a little bit to show people? Yeah, I remember that. Okay. Can you scroll down? Scroll up. Okay, scroll up, right, to show people the topics automatically choose, right? So as you can see here, this is a yes or no question, right? For the first one topic, it is ask a favorite thing. So each of the topic is already pre-built AI with the identification of the intention and attention already, unless you wanted to ask this chatbot to recognize certain special attention. So for example, right now the fish one, right? So you want it to be the one. So then So then you want to actually make a recommendation, right? Add that one. So let's say assuming that we collect this information, want to make a recommendation. And then when she was going to show you make a recommendation, here it is. Do you see the, when she, maybe you can mouse over the function a little bit. So it's called the recommend dish, right? Which means that this is a function. So you can insert any external function. Again, that's another way of democratizing this one, because some people may have those functions already. So you can actually just plug in your own function to make a recommendation. And now you might want to, I think we're done, right? In this case, you can do.
I'm going to update the questions.
Oh, right. So because it's the seafood restaurant, and then we wanted to actually update the seafood one, maybe you can also upload the CSV file. As you can see, this is for the user. It's content for the user's role, right? You can see here with the this one, it's very simple, question and answer. That's it, right? You can upload. Okay, you can preview. Now we're done, literally. We're doing very fast, but you can actually come back to view this. Now, maybe you can deploy it to the website. Great. Deploy. Okay. Do you have a website, JS Bean? Yeah, you use that. Maybe
yes.
It's easier because people are more familiar with it, right? So this is a TiST website. You can just copy paste our little snippet of code here, and you can actually deploy a chatbot. You can see on the right, your lower right corner is deployed, right? So when maybe you can just do a quick several terms just to see this one, give people an idea what works. We're going to run out of time, right? So this case, remember when she didn't do any customization on the other thing, just say, what about you? Yeah, you can say, how about you? This is kind of like a context sensitive, right? Again, it's a different one, even though you don't need to do customization, but the built-in conversation already automatically handles this one. Electricity, what's your favorite dish? Okay, and then you can go ahead. Oh, okay. You can. I mean, when she also showing a different question, is interrupting it, right? We deliver, and then let's go ahead and answer that one. Yeah, it said is I like the shrimp, yeah, which is a little bit different. Remember, the training sample doesn't have shrimp, but it understands that shrimp is close enough to other seafood. And allergic to anything. They say, what about you? You can see this one. It is. I hope it has the answer. Water, definitely water. Yes, the electricity and the water doesn't go well. And they say, how much is the delivery fee? Again, when she was trying to show you how it interrupts it, even with this just a very quick, literally 2 minutes of the creation of the conversation, and the AI, but the AI really understands the context and understands the flow, and it will be able to keep the flow because then have the recommendation, right? Remember that. Make a recommendation, right? Great. Okay, now let me go back, actually, hopefully wrap up because I see we're at the top of the hour already. So literally, I have just 2 slides left, right? So as you can see, creating the AI now, it's very easy. And as long as you have domain knowledge, you knew the roles of your computer, you know the roles of your users and the content as well. Then you're just focusing on the roles and the content, and then you can create a very fairly powerful AI. So we have seen a wide range of applications from student services to HCI research to actually HR application like the job interview or a job application process. So you're welcome to take a look at our publications in this space, and also not just our publications, other people's publications in this space, how they have used AI like ours to actually conduct a wide range of the studies and also perform a wide range of tasks. And we're definitely welcome. The reason we're here today is to encourage more people to get their hands dirty, either to create your AI or join us to make AI more accessible. So we welcome all kinds of collaboration. It doesn't matter where you are the AI experts or not. And please join us in this effort, right? As we see this one is, it takes the world to raise AI assistant, and definitely takes the world to democratize the AI assistants as well. And then there's a number of topics that we're very much interested in, and we'll welcome you to join us. You can find us on LinkedIn. And from the AI evaluation, you can check out this year's paper and the ACM Conference Kai about how can we automatically evaluate AI performance. And also we're talking about AI safety, because you don't want to make it a black box. You don't know how the AI assistant actually thinks, behaves. You want to open the box and then to make its operations transparent. How can we do that? It's a huge challenge. And then the last one is almost the ultimate question. It is, so what are the what are responsibilities of AI assistants, especially as they become more powerful, right? So then there's all the topics that we're very interested in, and we welcome the more people to join us in this community to really democratize AI, to potentially prevent and actually overcome what we call it in a potentially AI divide. And then I'm going to actually stop here by thanking my colleagues, especially my co-founder, Dr. Hua Haiyang, and of course, Wenxi here is our founding team, and as well as V. And then we have a number of collaborators, as well as our sponsors, who have actually generously sponsored our work, research, from research to actually converting research, translating research into products. And then I want to do a last one. It is because my other hat is the Editor-in-Chief for ACM Transactions on Interactive Intelligence System. It's called the TiiS. And currently we're calling for special issue proposals. If you know a particular topic, it's in the human-centered AI, you're interested in organizing a particular special issue, please get in touch with me.
Thank you, Michelle. So I believe the time is almost up, but let's try a few questions to answer. So we got a lot of questions here. I'm gonna just sample some of them. So one of the questions that get asked by quite a few is, can you describe the difference between your tool, Juji, and from other platform like Watson Assistant and Microsoft Bot Framework?
Very good question. By the way, I just want to say because we're running out of time, we don't have time to address every question, but I promise Yan, I will actually address every question after the talk by submitting the answers to the questions. So he will help us to post. So what's the biggest difference? It is actually there are two differences. So one difference is on the AI function side of it. So AI function side of it, that's why we call ourselves about cognitive AI, right? So there's a set of the skills. What I talked about it is most distinguished two sets of skills. One is the ability to handle the context, the conversational context, to actually recognize the focus of attention and remember the conversational context and be able to optimize the management of the conversational context is number one. That's why you can take a look at their paper on active listening. It's last year's paper, 2020's paper. Second aspect of our differentiating from an AI perspective, it is what we call it read between the lines, which means dynamically analyzing the user's conversation and infer the user's characteristics. So you can truly personalize the decision-making, the user guidance on the fly. Nobody can do that right now yet. I haven't recognized it. So this is one from an AI perspective, the AI scales perspective. From a second perspective, we haven't seen anything related to our work. People are trying to make the actually progress on that. So it is democratize the creation of the powerful one. So if you go to Google Dialogflow or Watson, or for example, the virtual power, what they call the power virtual agent at Microsoft, right? Because recently we just saw a demo from a usage from that. So in our case, it is the creators of our AI don't really need to have any AI skills and understand what is the intent and what is the entity. You don't want to write all those rules, write those things. So we will give you the pre-built. And also, even those you need to customization, like when she showed you, it's very simple. And most importantly, the creators without AI expertise, especially programming expertise, do not need to worry about how the flow routes from one to another, right? That's the biggest problem. Thinking about it is you have hundreds, thousands of questions. You have hundreds of thousands of, literally in our case, millions of intent. How the conversation will actually be routed from one to another one and keep track of context. We are completely automate that, right? So other part, you have to go to take a look. I would say for those of you who are interested in even evaluating the framework of different types of platforms and frameworks, take a look at the Wenxi's demo. Go to just replay the Wenxi's demo. Try to create what Wenxi created in 2 minutes on any other platforms. If you can't beat Wenxi in 2 minutes, please come to talk to us. We're going to have a bigger reward for you. Because so far we haven't seen that kind of a power in terms of really managing the conversation, really understand the users in depth, right? So that's for a quick differentiation in that particular case.
Thank you, Michelle. So let's just pick one last question. So this question is quite interesting. I'm also very curious. How should we evaluate accessibility in these types of systems?
What is stability?
Accessibility.
Accessibility. Accessibility. Accessible? Accessible,
yeah,
right?
accessible.
Very good question. It's a great question. I want to thank the person. By the way, the person, could you actually contact us? We give you, maybe we can give you a gift card. Anyway, thank you for asking this very thoughtful question and a great question too. Accessibility means two things, as I mentioned earlier, right? In our democratizing AI effort. One, we want to make it accessible to the people who don't have any AI expertise. So we actually conduct many usability studies with people who don't know AI, who don't know any programming, and to see if they can create a workable, working version, practically useful AI assistants. That's the first one to assess the accessibility, which means can they do it, right? How long will it take them to do it? And not just that, what's the quality of their AI, right? Because you want to test one. So actually, if you look at our paper of the Xu 2021, this is the collaboration with Colorado University. We have some of the studies there already. This is the first type of accessibility, which means to the creators of AI. Second accessibility is to the end user of AI who are chatting with the one. So that part is much trickier because they're much larger in population, right? So they're, for example, like in our chatbot, the demo I showed earlier on our website, there are probably literally thousands of the people, maybe hundreds of thousands of people have chatted with. So how would I know they're not accessible to those people? So right now we're actually developing methods to measure that, whether they are accessible, just one criteria, right? We call another one, for example, appropriateness. And accessible also means that is maybe they speak their language, maybe they actually tailor or cater to their culture, maybe cater to their emotional state, right? So in this case, it is, so we have to do more work on that because it's much harder. Again, Xu's work touches upon a little bit, but not there. We're not there yet. So that's why, as I said, it's a great question and opens up many interesting research topics, as well as actually pose many, raise many also challenges as well. Thank you for asking this question. Again, whoever asks this question, please feel free to email.
Okay, thank you, Michelle. I'm afraid we have really run out of time today. I would like to thank Michelle again for her informative presentation and insightful answers to the many questions. So we will actually answer more questions after the talk. A special thanks to each of you for taking the time to attend and participate today.
Thank you, Wenxi, for moderating the talk and for introducing us and for doing a demo as well.
And this talk was recorded and will be available online in a few days at learning.acm.org. You can find announcements on upcoming talks and other ACM activities at learning.acm.org or acm.org. Also, please fill out our quick survey where you can suggest future topics or speakers, which you should see on your screen. On behalf of the ACM, Michelle Zhou and myself, thanks again for joining us, and I hope you will join us again in the future. This concludes the talk.